Hello everyone, my name is Deepak Mane and this is second lecture on matrices. Points we have to discuss in this lecture are: first point, equality of two matrices, then addition and subtraction of two matrices, scalar multiplication, and then matrix multiplication. Let us start with our first point, equality of two matrices. Okay, so two matrices are equal if they have same order and element placed on corresponding positions are same. So there are two necessary conditions for equality of two matrices. First one, order should be same, their order should be same, and element placed on corresponding position should be same, and vice versa. Okay, so let us consider two matrices of same order which are equal. Okay, the order of left hand side matrix is 2 by 3 because this matrix containing 2 rows and 3 columns, and the order of right hand side matrix is also 2 by 3. That means the order of these two matrices are same and these two matrices are equal, implies their corresponding elements are same. So the corresponding element means the position of this element placed on first row first column. So the corresponding element for this element is this one, B11, because this element is also placed on first row first column, and these two matrices are equal. So that according to definition, when the corresponding elements are equal, the corresponding matrix will be equal, and when the matrix are equal, the corresponding element will be equal. So according to this definition, A11 is equal to B11, A21 is equal to B21, A12, that means the element placed on first row second column, is equal to element placed on first row second column, that is B12, A22 is equal to B22, A13 is equal to B13, and A23 is equal to B23. This A23 placed on second row third column, and B23 is also placed on second row third column. Next, addition and subtraction of two matrices. So in mathematics we all know for addition and subtraction terms should be like. Okay, like terms means terms containing same variable with same exponent. So let us consider two terms, 5x and 2x. So this term containing same variable with same exponent, that means these two terms are like terms. So it is possible to find their addition and subtraction. That is, addition 5x plus 2x is equal to 7x, and the subtraction 5x minus 2x is equal to 3x. But when we consider the terms 5x and 2y, since these two terms containing different variable, that means these terms are unlike, so it is not possible to find their addition and subtraction. Similarly, to find addition and subtraction of two matrices, there are some conditions. Okay, and when given two matrices satisfy that condition, then it is possible to find their addition and subtraction, and the condition is their order should be same. If the order of two matrices are same, then it is possible to find their addition and subtraction. Okay, so let us consider two matrices of same order. The order of this matrix is 2 by 3 and the order of these two matrices is 2 by 3, and we are going to find the addition of these two matrices. Okay, so this addition is obtained by adding corresponding elements. Okay, so we adding this element placed on first row first column, that is B11, in element placed on first row first column, that is A11. Now here we adding B12 in A12, then we adding B13 in A13, and similarly we adding B23 in A23. So the addition of these two matrices will be this one. Okay, and the order is also 2 by 3. Similarly, for subtraction, we subtracting this element B11 from A11, B12 from A12, B13 from A13, then B21 from A21, B22 from A22, and B23 from A23. So subtraction of these two matrices will be this one. whose order is 2 by 3. Okay, so for addition and subtraction of two matrices, their order should be same. Next point, scalar multiplication. So let us consider one matrix of order 2 by 3 and a scalar k, and we have to multiply this matrix by k. That means we multiplying all these 6 elements by k. So k into this matrix, answer will be, we multiplying all these 6 elements by k. So this is scalar multiplication. Okay, now in matrix multiplication there is one condition, and when the given two matrices satisfy that condition, then it is possible to find their product. Okay, and the condition is the product of two matrix A and B, that is AB, is possible if and only if the number of columns in A is equal to number of rows in B. तर यामध्ये A मध्ये जितके कॉलम आहेत तेवढे रो B मध्ये असतील तरच आपण काय करू शकतो, इट इज पॉसिबल टू फाइंड द प्रोडक्ट ऑफ दॅट टू matrices. Now if the order of matrix A is m by p, that means this matrix A containing m number of rows and p number of columns. Okay, and the order of matrix B is p by n, that means number of row is equal to p and number of column is equal to n. So in A and B, the number of columns in A is equal to number of rows in B. That means the product of these two matrices is possible, and the order of that matrix will be, that matrix means order of matrix AB will be m by n. Okay, so this product containing number of rows of A and number of columns of B. So A containing m number of rows, so number of rows in product AB will be m, and number of columns in B is n, that means number of column in AB is n. So the order of this AB is m by n. Now in this product AB, A is called as prefactor and B is called as postfactor. Let's consider two matrices, matrix A whose order is 3 by 2 because this matrix containing 3 rows and 2 columns, and matrix B whose order is 2 by 3 because this matrix containing 2 rows and 3 columns. Okay, now it is possible to find the product AB. Answer is yes, because the number of column in A, that is 2, and number of rows in B, that is 2. So number of columns in A is equal to number of rows in B. So it is possible to find product AB. And similarly, it is possible to find product BA because the number of columns in B is equal to 3 and number of rows in A is equal to 3. So here the order of A is 3 by 2, order of B is 2 by 3. So the order of AB is 3 by 3. Okay, number of rows in A and number of columns in B. And the order of BA is number of rows in B, that is 2, and number of columns in A, that is 2. So order of BA will be 2 by 2. That means the product BA containing 2 number of rows and 2 number of columns. Now we are going to find AB. Okay, so here we write AB. This is matrix A, this is matrix B. This is called as prefactor, this is called as postfactor. आता या ठिकाणी करायचं काय बघा तुम्हाला की ह्या दोघांचा प्रोडक्ट करायचा आहे. सपोज द ऑर्डर ऑफ AB will be 3 by 3. That means this matrix containing 3 rows and 3 columns. Okay, आता हा जर का एलिमेंट घेतला, this element placed on first row first column. So to find element on first row first column, we taking first row from prefactor and first column from postfactor. Suppose this element placed on third row second column. So to find this element, we taking third row of prefactor and second column of postfactor. So we are taking columns, we are taking rows of prefactor and columns of postfactor. आता इथं ऍक्च्युअली तुम्हाला करायचं काय आहे, तर यासाठी आता आपल्याला एकतर समजलेलं आहे की आपल्याला काय करायचं आहे, वी टेकिंग रो ऑफ प्रीफॅक्टर अँड कॉलम ऑफ postfactor. So to find this element, we taking first row of prefactor and first column of postfactor. तर या ठिकाणी बघितला तर यामध्ये जितके एलिमेंट्स आहेत, या फर्स्ट रो मध्ये जेवढे एलिमेंट्स आहेत तेवढेच एलिमेंट काय असणार आहेत, फर्स्ट कॉलम मध्ये असणार आहे. तुम्ही काय करायचं, जस्ट find the sum of product, means we multiplying this element by this one and this element by this one, and just add it. Okay, so this element is 2 into a, that is 2a, plus 3 into d, that is 3d. लक्षात आलेलं आहे. आता समजा आता हे सगळं काय मी सांगत बसणार नाही, तुम्ही बघायचं आहे. सपोज हा एलिमेंट घेतला तर this element placed on third row second column, so we taking third row of a prefactor, that is 6 7 containing two elements, and second column of this post factor containing two elements b and e. So just find the sum of product. So 6 into b 6b plus 7 into e 7e. So here answer is 6b plus 7e. Similarly, आता हा element घेतला की this element placed on third row third column, so we taking third row of prefactor, that is 6 7, and third column of post factor, that is c up. Okay, this third row containing two elements and this third column containing two elements. So just find the sum of product. So answer is 6c plus 7f. Similarly, we can find ba. Okay, so this is matrix B, this is matrix A. So the number of rows in BA, the number of rows in B 2. So the number of rows in matrix BA is also 2. And number of columns in A, that is post factor, is 2. So the number of column in matrix BA is also 2. आता या ठिकाणी बघितलं तर this element placed on first row first column. So we taking first row of prefactor and first column of post factor. So this first row containing three elements and first column containing three elements. So just find the sum of product. Okay, so we multiplying this element by this one plus this element by this one plus this element by this one. So the answer will be 2a plus 4b plus 6c. इथं दिलेलं आहे. Similarly, we can find the remaining elements. Okay, for example, suppose this one, this element placed on first row second column. So we taking first row, that is ABC, and second column, that is 3 5 7. So the sum of product is 3a plus 5b plus 7c. So this is matrix BA whose order is 2 by 2. Now just compare these two matrices AB and BA. The order of matrix AB is 3 by 3 and the order of matrix BA is 2 by 2. Surely these two matrices are not equal, because for equality order should be same and corresponding elements are also same. Okay, so here the order of AB and BA are different. That means these two matrices are not equal. So it is possible to say that the matrix multiplication is not commutative. Okay, next, now here two matrices are given, matrix A and matrix B of same order 2 by 3, and now we are going to find the sum of these two matrices, that means A plus B. So to find A plus B, just add the corresponding elements. So here we write 2 plus 3, here we write minus 1 plus 2, here we write 3 plus minus 1, that is 3 minus 1, here we write 0 plus 6, here we write 2 plus 3, and here we write minus 5 plus minus 2, that means minus 5 minus 2. Just perform this addition. So this matrix is nothing but the addition of these two matrices, that is A plus 1, A plus B, that whose order is 2 by 3. Now we find A minus B. So subtract the corresponding element. That means we are going to subtract this 3 from 2, 2 from minus 1, minus 1 from minus 3. So the A minus B is equal to, here we get 2 minus 3, minus 1 minus 2, 3, this minus minus plus 1, 0 minus 6, 2 minus 3, and minus 5 minus minus 2, that is minus 5 plus 2. So A minus B is, when we performing this addition or subtraction, we will get this answer. Okay, so this is subtraction of these two matrices, that means A minus B. Now we find 2A, that means we have to multiply this matrix by matrix A by 2. That means we multiplying all these 6 elements by 2. That means answer is 2 into 2 4, 2 into minus 1 minus 2, 2 into 3 6, 2 into 0 0, 2 into 2 4, 2 into minus 5 minus 10. And now we find 3b. That means we multiplying all these 6 elements by 3. So answer will be 3 3s are 9, 3 2s are 6, 3 into minus 1 minus 3, 3 into 6 18, 3 3s are 9, 3 into minus 2, answer will be minus 6. Now here two examples are given. In example number 1, the order A is row matrix whose order is 1 by 2 and B is column matrix whose order is 2 by 1. Okay, and in second example the order of matrix A is 2 by 2, that means it is a square matrix, and the order of matrix B is 2 by 3 because since this matrix containing 2 rows and 3 columns. And now we are going to find the product of these two matrices. So in example number 1, number of columns in A, that is 2, and number of rows in B, that is 2. That means number of rows of A is equal to number of columns of B. So it is possible to find product AB, and the order of AB is 1 by 1 because the number of rows in A is 1 and number of column in B is 1. So here the product of this matrix AB whose order 1 by 1 means 1 row 1 column. So this element is obtained by, so to find this element we taking first row of A and first column of B. So first row of A containing 2 elements and first column of B containing 2 elements. So just find the sum of product. So here we write 2 into 1 plus minus 3 into 2. So 2 into 1 answer will be 2 and minus 3 into 2 answer will be minus 6. So 2 minus 6 is minus 4. So the order of this matrix is 1 by 1. Okay. Now here it is also it is possible to find product AB because the number of columns in A which is equal to 2 and number of rows in B which is equal to 2, and the order of AB is 2 by 3 because the number of A in 2 and number of column in B 3. So order of AB is 2 by 3. So here we write AB, A, this is B. So AB is equal to this AB containing 2 number of rows because the number of rows in A are 2. ओके, कारण आपण प्रोडक्ट करत असताना काय करत असतो, A चे रोज घेत असतो आणि B चे कॉलम घेत असतो. त्यामुळे ह्या AB मध्ये काय येणार, A मध्ये जेवढे रोज आहेत तेवढे रो आणि B मध्ये जेवढे कॉलम्स आहेत तेवढे कॉलम. ओके, सो टू फाइंड दिस एलिमेंट just taking first row of A and first column of B. So here we get 2 into 3 plus minus 1 into 1. Here we write this is second row first column, so second row of A that is 3 2, first column of B that is 3 1. So here we get 3 into 3 9 plus 2 into 1 2. Similarly here we get 2 into 2 4 plus minus 1 into minus 3. Here we write 3 into 2 plus 2 into minus 3. Here we write 2 into minus 2. Here this element placed on first row third column. So first row 2 minus 1, third column minus 2 4. So 2 into minus 2 plus minus 1 into 4, and this is element on second row third column. So 3 into minus 2 plus 2 into 4. Now just performing this multiplication and addition, so after simplification we get this one, and the order of matrix is 2 by 3. Okay, बघा इथं आता 3 2 जा 6 minus 1 answer will be 5, 2 2 जा 4, this minus minus become plus, so 4 plus 3 answer will be 7. So here 2 into minus 2 minus 4, and this minus plus become minus 4, so minus 4 minus 4 minus 8. Here 9 plus 2 11, here 6 minus 6 0, and here minus 6 plus 8 answer will be 2. So just revise all these points, okay, and do practice on addition, subtraction, scalar multiplication and matrix multiplication. Thank you.